warm welcome to our presentation. We're talking about building the backbone for net zero, and what that means we'll explain in a bit. But first, I'd like to introduce myself and my co-presenter here. My name is Erik Schmiegelow. I'm a director at Hivemind Technologies. And Christian?
Afternoon. My name is Christian Fitzgibbon, industry expert in IoT and e-mobility.
All right. Without much further ado, we'll talk about what the backbone of net zero actually is. And it is all about streaming data and real time. Because essentially, real-time ESG is about observability and response. So what we're talking about here is essentially understanding that decarbonization isn't about strategies, business plans, it's about systems. Systems communicating with each other at all times in an automated fashion, right? Because without that, ESG goals will fail.
Yeah, absolutely. The second point here, talking about spreadsheets and quarterly reports, I'm sure you're all abundantly aware of what it's like pulling together data for ESG reporting into spreadsheets, whether that's monthly, quarterly, 6 monthly, whatever is required. The pain that delivers of when you've got missing reports, chucking report requirements over the fence to the next team and so on and so forth, it does not equal real-time decision making.
Exactly, because without the proper infrastructure, ESG is essentially greenwashing. It's just PR. So when we're looking at that, what does that entail? And how is net zero a mirage without proper data infrastructure?
Starting off, number one there, the fragmented data landscape. It's pretty well much what I just alluded to, where you've got data disparately across your organization or even externally to your organization. And with ESG, you want that data to be readily available, and you need to be able to adapt to compile that data quickly and easily. And fragmented data and the landscape doesn't allow that to happen. Similarly, without automation, you've got manual reactive workflows. So what you've got is you've got people pulling together this fragmented data into a quarterly carbon credit report or something like that, that induces human error, it's clunky, it's time consuming, it's not efficient. And then lack of observability. You'll have that scenario where there's some missing data and you don't know about it until you come to compile these reports. And it's only at that time that you realize you have missing data. You need to go back, or the data's not correct for whatever reason, and you need to go back and figure out why. And these are three of the problems of legacy systems.
And lastly, that results to delayed compliance, right? Because essentially, if you have regulatory reporting in place, or you have to report back to your investors, generating the reports is slow. It involves a lot of Excel, and you don't know where the data eventually comes from, whether it's reliable. Single source of truth problems arise. So essentially, what we see is that most companies face the problem of having an infrastructure that is not built for real-time ESG, not purpose-built. Essentially, it's also about being able to react to things that happen. If, let's say, you have a factory plant and it starts consuming more fuel than expected, you want to be able to react to that immediately rather than noticing 3 weeks later and saying, oh, we had a problem 3 weeks ago, right? So essentially, ESG is not a problem of lack of will. It's a problem of having the proper infrastructure and the systems in place to be able to implement true real-time observability with ESG. So what does that entail, right? It's moving reporting ESG, which is essentially, as I said, like the kind of fragmented, manually inputted thing that a poor person has to put together in regular intervals to report, to something that is continuous, that is live, that is proactive, and it can be also assisted with machine learning and predictive systems. You want to be able to say, okay, if my data points that I'm getting from my production sites look like this, and we have a progression to a certain, if we go on like this, we're going to miss our goals. We're going to hit some thresholds, and we're going to be in trouble. We need to be able to mitigate the risk immediately. So it's about having live dashboards with immediate, near real-time visibility and compliance that's built in to the process and to the value chain rather than an add-on that is essentially delayed, right? Because that essentially, the trick is stop reporting, start responding.
As you can see, and I'm sure your experience, most ESG reporting today still relies on manual inputs and quarterly cycles. And the legacy systems that support that, spreadsheets and databases of a simple nature, they can't detect anomalies. They can't see in what Erik's already mentioned, near real time, when something goes wrong. They can't surface insights. So you don't, with Excel and CSV, get a beautiful dashboard with real-time graphics showing you when something has gone wrong, when you've got your low watermarks and your high watermarks on a graph of data and something stops working. You can't see that with Excel. You're looking at historic data. You're not looking at live data. And spreadsheets, they can't adapt to evolving regulation. This is one of the key points for me, especially as a key takeaway on having a data platform that allows you to adapt. When you're in an emerging market, you're a scaling company, you're a startup company, or even a well-established company, you need to be able to adapt to the demands of the authorities that are establishing what an ESG looks like. And with the legacy systems, you just can't do that.
Exactly. So when we're looking at how to solve this, we have some key principles in the backbone system that's built for real-time observability. So we need tracking and measuring. We can't use estimations, which is what we usually do otherwise, right? We need connectivity. All the relevant systems, be it like systems or mobility, sensors, telematics, they need to be integrated into an automated ingestion pipeline that feeds into one single data repository. That single data repository approach is super important to have a single source of truth and reliable data. Of course, it comes with a data model, so you basically need to understand your business domain and design that data model to reflect your business. And lastly, data governance. You need to be able to define roles and responsibilities and ingest and manage the data flows accordingly. So essentially, it flows into one central system with which you can observe and manage all flows within the organization. Reporting and reactivity is key. So with taking a different approach here, it's not about collecting all the data and doing that in batch cycles. It's about reacting to events, specifically as they happen or even before they happen, with predictive capabilities. So those are like the fundamental principles of a backbone system for real-time ESG. So essentially, what that looks like is that you basically connect all the systems into a single data platform. It's captured and propagated as it occurs, and they stream from the data sources across those data layers into a processing layer for aggregation. And lastly, that's where the AI comes in, where you essentially say, okay, and in addition, I want to be able to create reports, use artificial intelligence for prediction or reporting purposes that feed into outputs that are used by the business. So coming to that, we're going to want to take a look at IoT.
So this is my specialist field, according to the opening slide. But in a real world scenario, you want to know how do you get this data? How do you implement that data through devices, getting it into this, what Erik's called this data platform, so that you can respond, observe, and therefore then report on things. So IoT devices. This bus here, for example, it will have a telematics device on it that will send its data into a central place of its speed, its battery state of health, its battery state of charge, all these other elements that you would expect to see from a vehicle, all the telematics, the speed, and from that you can derive things like harsh events. You know, is the driver braking too hard, accelerating too hard, so on and so forth. And that leads on to edge decisioning. So you can have compute on the edge as well. So you can make decisions on devices, like on the bus, for example, if something is a harsh event and therefore you need to report on it. Or you can do that in the cloud as well. And then moving on to the mobility systems integration, the things that really make this very important, especially when we're looking at things like electric vehicles. So the e-mobility side of my specialism is the longevity of a battery. How do you make that battery last as long as you possibly can on the bus? There are so many factors that you need to look at. The driver performance, every driver drives differently. The weather conditions, the size of the bus, the route that the bus travels on. All of these things lead into all the decisions you need to make on how much you charge the bus when it's in the depot. And all of this leads on to manufacturing optimizations. So you can then lead all of this information back into the manufacturing cycle so that you can optimize the capacity of a battery so that it meets a specific route, for example. Very edge case and unlikely to happen, but it's that kind of thing where you can start to look at what waste have we got in the manufacturing system where you don't need to put certain things into production. And all of this can come from IoT. You can start censoring and getting all of that data into a data platform, and then you can start finding these answers to these problems.
Thank you. And the interesting thing about this is that we basically have to think about all these stages in IoT as connected computers. Even the bus is essentially an iPhone on wheels, right? And you can integrate that into your data flow. So essentially, what we're looking at is moving from ESG reporting, as we discussed, to intelligent action. It's about understanding how systems are operating in parallel and in isolation to each other and reacting to system integration as a first port of call. Reporting really needs to move away from Excel into essentially a continuous reporting, continuous single source of truth platform that helps you make those decisions as they appear. Now, looking at generative AI, right? It's not just about chatbots and asking questions in ChatGPT. It's integrating generative AI as a capability tools within a compliance framework and making it at the cornerstone of the interaction between humans and the data platform. So essentially, when we build in ESG intelligence with AI into the backbone, there are basically two essential, let's say, avenues. One is continuous aggregation and calculation of ESG metrics for reporting, and the other is building a system that is capable of observing the data flows within your ESG metrics and reacting to them, triggering alerts, and also answering natural language queries from users and translating them into reports that are generated and facilitated without requiring an engineer to do that. So looking at those two different use cases, when we start with the observer agent, we're basically using generative AI limited capability reasoning capabilities to emulate an automated system that resembles what a human would usually do. Essentially, having a program that observes the data flow and marks those events that are suspicious, let's say fuel consumption or high energy demands or any kind of other events that might happen within the stream, and report that with all the context that's associated with that event to an observer agentic application. Now, the observer agentic application is essentially a large language model, like we know from ChatGPT, that is capable of using tools, right? It says, okay, I'm getting this input, and the prompt is to say, if you have this input, please validate whether this is a suspicious event that needs further action. And it will then reason and tap into tools that are other applications or queries to execute them against the backend systems, to then pull all the information together to decide whether that event is indeed suspicious and needs to be reported, or whether it's fine. And in the end, it pushes that result into another pipe that gets combined with the regular data flow to basically allow us to implement alerting and reactivity with as much automation and assistance as possible by leveraging a standard streaming data flow with generative AI intelligence and agentic systems. All of that is possible nowadays thanks to the rapid advancement in generative AI technology, most notably MCP, which stands for Model Context Protocol, which is essentially a new standard that allows us to plug in multiple different systems into a large language model for reasoning and tooling. So what that gives us is the ability to have a generative application that works like a watchdog. It's capable of detecting, interpreting, and acting on events and risk and compliance risks within our flow. The other use case for generative AI is what we call assistive agents. It's probably what most of us know from using other tools within, let's say, Office 365 or Google Gemini, where you basically have a companion that allows us to formulate queries in natural language, in English, and that executes it against our data set. And the same thing happens and is feasible and possible in reporting system. It allows us to formulate a query, say, I need, let's say, the output, the CO2 footprint of these factories and those locations over the course of the last 2 weeks. You just say that, and the assistive generative AI application will then translate that into a machine query and pull it from the data platform and create a report that you can then embed and process. So this also allows, opens, let's say, reporting to a wider audience. It requires less analyst working time, and or less engineering time, because we basically enable reporting capabilities for everyone within the organization. So lastly, when we're looking at LLMs, automated reporting basically turbocharges the ability to create reports and draft policies in minutes, not in weeks. We have traceability and audit-ready logic, which gives us the ability to create transparency for regulators and auditors. So it also turbocharges the organization's capability to answer to external queries, especially if you have an investor board that is keen on understanding how the business meets their sustainability goals. All of that is possible with a data platform with a backbone for net zero. And this has real-world impact because you can continuously calculate and aggregate your ESG metrics. You do not need to have someone do that in the back office because it's built into the system, and allows us to continuously observe the data flow and how things happen within the organization. So you can capture and react to events as they happen and not 3 weeks later. So lastly, what that looks like is a blueprint, which we present today. Maybe, Christian, maybe you want to walk us through the ingestion side of the platform?
Yeah, sure. So not necessarily with SAP and Microsoft SQL, etc., but if you could imagine, you've got very similar to this BYD bus back here, you've got vehicle telematics, and that'll be connected via Kafka Connect, those little green circles on the left-hand side there. And that data just gets ingested, raw format, via a Kafka broker for where I've been for the last recent times, into Apache Iceberg, which effectively just becomes a raw data vault of all of your raw data. What that allows you to do is it allows you to respond really quickly and adapt when you have requirements coming up, because in the ESG world, things like carbon credits, it's evolving. I was involved in one of the first UK EV carbon credit audits recently, which is still ongoing, but to have this data platform in place, or it's a bit more complex what we've done, but this is a blueprint, means that we can adapt very quickly to the requirements for that carbon credit auditing. And as a result, we've saved many man days in what would have otherwise been very complicated.
And in addition, what we're looking at, this platform is ready-made thanks to the MCP protocol to integrate with agentic applications. So we can build the observer and the report generation use case that we demonstrated using MCP, and allowing the data platform to answer real-time requests via the protocol from the agentic apps. So essentially, this blueprint gives us the ability to integrate a common approach and an infrastructure that answers the requirements of modern organizations in terms of real-time ESG and observability. So what that gives us is the ability to be reactive in IoT and in consistent reporting and continuous regulatory alignment, which is not the case with traditional approaches. So essentially, we're moving from insights to action, the ability to react immediately, and embed the necessary infrastructure, the technical infrastructure, in every process across the entire value chain of the business. So that concludes our presentation today. We're just about us, Hivemind. We're just opposite this stage. We're not just consultants, we're builders. So we help companies build the infrastructure and the necessary assets for real-time observability and ESG compliance. Happy to have conversations with you and meet you at our booth. Thank you very much.